then depending on the user input, when a threshold is exceeded, it shows you a certain segment and then goes back to the neutral state. And if there is a period of inactivity, it goes back to sleep. The learning that we thought that should be appropriate for this kind of system is like this. In the beginning, we know how many segments we have. So what we do is we associate each segment with a certain feature vector, which is like the mean response that the user, well, the response that the user should perform to elicit this segment. So if I want segment 1 to become active, let's say, I have to smile. Initially, I don't know this, but there is a way of giving feedback to the user. So the user will discover the behaviors that will elicit response from the system. But we're also going to have sort of like a threshold around the expected response. So if, let's say, smile is the response I'm expecting, maybe I have a 10% buffer around it, shown with the blue circle. So if the feature vector exceeds a threshold of 0.9 for smile, I will activate that segment. And for instance, the second segment is activated by 90% or more surprise. Now, I will also record what the user did during the operation of the system, and these are shown by dots. So what I can do in the offline mode is to retune the system's expected response from the user by what the user has supplied during the operation. So if I'm not able to create a disgust, let's say, basically this will shift the expected response towards something close to disgust, but not quite, but what I can produce. So here there will be a clustering, but we will take care that the clusters are non-overlapping and there are sufficient buffer between them. This part we didn't implement yet, but this is what we think it should be. For the interface, currently we use two external programs. The emotion system is now encapsulated as an API, and it provides the feature vectors from a TCP/IP link, from a telnet basically. We also use a split cam to allow two programs access the camera at the same time. So emotion and our own system are accessing the camera input at the same time. We also have some glyphs underneath the video frame to provide some feedback to the user. So if, let's say, the behavior is 3 is about to be unlocked and it requires an anger expression to be unlocked, then we're tying glyph brightness to the distance to the anger expression. So if your expression is close to anger, the glyph gets brighter. And when it's fully bright, you're unlocking the new segment of behavior. Once you unlock a glyph, the same user activity will elicit the user response. So first you need to smile to unlock the first behavior, let's say. Then you need to be angry for the second behavior. But then each smile will repeat the segment that was created with the smile, and anger will repeat this anger segment. That means if two users are interacting with the system, they can tie different behaviors to different video segments. It just depends on which behavior you performed first. Now we come to the difficult part. We'll try to make a demo of the system. I'll open this a little bit so we have more. Okay, so now the system is in standby mode. You should probably direct it. So, can you see the motion system there? Oh. So this is the Bezier curve that is fit on his face. Now the baby is awakened because he has detected a face, and it goes to the neutral mode. And there you see the glyphs. And we have put their names so that you know which emotion is tied to which input. But in normal operation, we don't think that there will be emotional tags there. There will just be glyphs because their number just relates to the number of video segments that we have. Here, each color is a different type of video. Basically, it comes from a different video, so the background will be different, etc. But now I'm just trying to activate the surprise segment. It's not so easy yet. So emotion actually requires pretty stable illumination conditions to work properly. So it may be a good idea to utilize additional cues like the activity levels, etc., that are easier to detect and tie them to the activation of segments. Of course, during the operation, the second video of the base mesh will not be visible to the user. So we're going to conduct some usability studies to see what kind of behavior is actually more interesting to the user. If you don't know what activates the system, perhaps it's easier to experiment. Then you do random things, and then suddenly you unlock one behavior. And then, as time progresses, you basically get to learn what activates that particular behavior. Does that sound too weird? We also want to keep the segments as short as possible to elicit some fast response from the user. I think you're not going to be able to activate the surprise segment.
No, I'm liking this.
Hangi? Hangi arkadaki beyazlık hiç gözükmezse olacak muhtemelen.
Evet, şöyle biraz şöyle yapsın. There is even more light. Anyway, you get the picture. It's okay. Okay, so the future work is basically we're going to implement this simple clustering method for the learning module. We have some tests involving the segmentation parameters, the dual frame mode. The system is now a little bit slow, so we had to use Petr's computer to properly work. When we add the visual features, basically, and the emotion, the processing requirement becomes too heavy, so then it becomes not impractical to run it on a single machine. We also have a Wizard of Oz module implemented that allows us to select the responses by hand. So we can basically test the interaction of a user by giving the user response ourselves. And well, semaine integration is still an open issue. We don't know whether it's practical to do that or not. We can just encapsulate the system in a single API and put it into semaine, but maybe then it will be even more bulky. So we have to see. That concludes my presentation. If there are any questions, I'll be happy to answer.